Alright, so to start 8.1, finding angle measures in polygons. In polygons is interior, okay? First theorem you have is polygons interior angles theorem. The sum of the measures of interior angles of a convex n-gon is n minus 2 times 180. The reason why is because what you do is you create triangles. So if I start here at vertex 1 and draw a diagonal to every other vertice, you're going to create triangles, and we know the sum of the angles in a triangle is 180. So if you take each of these angles, you'll eventually hit all the angles at all the vertices of this polygon. You have 1, 2, 3, 4 triangles. So you got 4 triangles, 4 times 180. So you get 6 minus 2 gives you 4 times 180, gets you the sum of a hexagon, which would give you 720 degrees. So the sum of the interior angles of a hexagon is 720 degrees. The corollary to the theorem is the sum of interior angles of quadrilateral. Quadrilateral has 4 sides, so 4 minus 2 times 180 gives you 2 times 180, which equals 360. So a quadrilateral sum of its interior angles will always be 360. What we're going to do here is we're going to do 2 examples. Before we move, literally going to do 4 examples. So we're going to do example 1, 2, 3, then 4. So what we're going to do is we're going to start with number 1. Number 1 is this coin. So this coin shown is the shape of a regular n-gon, 11-gon, excuse me. Find the sum of the measures of the interior angles. So I'm literally going to use the formula back here up with the polygon interior sum, n minus 2 times 180. So I'm going to take 11 minus 2 times 180 degrees, which equals 9 times 180 degrees, which equals out to be 1620 degrees. Okay? If I wanted to find a single angle of a regular polygon, n equals number of sides. Okay? With it being the number of sides, it is also equal to the number of angles that you have. They're all equal because it's regular, so you would take 1620 divided by n of 11. And to do that now, I'm going to grab a calculator here. Okay, let's type it in, enter, and we get 147.27. All right. So moving on to the next question. The sum of the measures of interior angles of a convex polygon is 1440. Classify the polygon based on the number of sides. So we have 1440 equals n minus 2 times 180 divided by 180. 8 equals n minus 2. So n would equal 10, and the sides that, the polygon that has the number of sides of 10 would be a decagon. So that would be my answer. Number 3, use this diagram at the right. Find the measure of angle S and T. These 2 angles are congruent because of the angle markings. This is X and this is X. You can use whatever variable you want, but I'm going to use X. Move this over here so I can do some math. So I have 9, 3 plus 1, 5, 6 plus 8, 5 plus 2 X's equals this answer here. This comes from n minus 2 times 180 degrees. I have 1, 2, 3, 4, 5 vertices. So 5 minus 2 times 180 gives me 500. Excuse me. 40. So this is 540. So taking these numbers, adding this up, this comes out to 334 plus 2x equals 540. Subtract the 334 over, you get 2x equals 206. Divide by 2, x equals 103 degrees. So the measure of angle T and the measure of angle S is 103 degrees. This example here, the measure of 3 of the interior angles of a quadrilateral are 89 and 110 and 46. Find the measure of the 4th interior based on the corollary to the theorem 8.1, or the interior angles of a quad. The sum of the interior angles of a quadrilateral are 360 degrees. So 360 would equal x, my unknown angle, plus the 89, 110, and 46, which add up to 245 degrees. Subtract 245 from both sides, you get 115 degrees equals x. All right, last but not least, here's what we got. Pardon my nose. The sum of the measures of the exterior angles of a convex polygon at every single vertex is 360 degrees. If I took all of these angles and I put them at a single point of the center, despite their measurements, I would create a circle which is 360 degrees. So no matter what, in any polygon, the sum of the exterior angles are always 360 degrees. In class, we played a game of musical chairs. So if this was 5 chairs and we walked in a circle on the outside, all the angles, if I drew them out, let's see. There we go. It's like this is off. Okay. I'd walk in a circle, and that's how I get my 360 degrees. All right.